I hope all of you have marked your attendance. So good morning once again to all of you, and now that we have finished with first 3 units of DECO, that is digital electronics and computer organization. Now let us start with the remaining 3 units of this particular subject. First 3 units were dedicated to the digital electronics, and now the remaining 3 units, unit number 4, 5, and 6, are dedicated to computer organization. So let us start today with the 4th unit, that is of the computer organization. And in the beginning, we shall see the brief history of the computers, or brief history of computing. In the beginning, there were computers, but whether you can call them as a computer or computing machines, so that is a question. But the evolution of the computer, it started with those particular machine which were used for the purpose of computing. So we do the computing manually, that is basic arithmetic operations and all other operations. But if these operations or the operations that we do, if they are done with the help of machine, then that particular machine, we used to say that that machine is computing something, or the machine which does that particular job, we call it as computer. Okay, so the one who computes is the computer. Okay, so let us see the history of the computers. So in the second half of the 19th century, the Charles Babbage constructed a mechanical computer, and that particular computer was called difference and analytical engine. Okay, so that was a mechanical computer. No electronic devices were used in that particular computer. Then in 1936, Alan Turing provided a definition of a universal computer called Turing machine with the algorithm execution capability. So that was the kind of computer proposed by Alan Turing. Then before the World War II, mechanical and electrical analog computers they were used to compute the ballistic trajectories, momentum, inertia, and like that. Okay. Whereas in 1946, that is immediately after the First World War, ENIAC, so this computer, first electronic general purpose computer, was proposed. This particular, the characteristics of this computer was that it was containing 18,000 vacuum tubes. Okay, so these were the devices, vacuum tubes. You might have uh, uh, studied about this CRTs, that is cathode ray. Uh, CROs, you might have seen cathode rays oscilloscope. So the vacuum tubes are similar of that particular kinds, which has the anode and cathode inside it in a tube, which are vacuum tubes. So vacuum tubes, they serve either as a diode or as a triode, which is equivalent to now a transistor. You call it as a transistor now, that is a semiconductor device. But before semiconductor devices, these vacuum tubes were used in the electronic devices. In addition to the 18,000 vacuum tubes, there were 1,500 relays, and the weight of that computer was 30 ton. Okay, so it was as large as 30 ton. So that was the first electronic general purpose computer proposed in 1946. Okay, before that, all computers, they were mechanical computers. In 1947, John von Neumann introduced a design of a stored program computer. So this base design is known as von Neumann architecture. Okay, so two different architectures, they are very common with the computers. One is the von Neumann architecture, and the another one is the Harvard architecture. So we shall see the difference between these architectures of the computers, where a stored program is used and the memory used is common for storing the data, and the program is called the von Neumann architecture. Okay. It started a new epoch of computing and the computers. All modern computers nowadays use this type of design, that is von Neumann architecture. However, there are other popular computers also which use the Harvard architecture. So before we see the various different types of architectures, let us first see what is this von Neumann architecture. John von Neumann introduced a universal computer. It must comply with some principles and criteria. If it complies with this particular criteria, then it would be called the von Neumann type of architecture. The computer consists of the memory. Okay, so all of you are aware that what a particular computer consists of. Okay, so it consists of memory, ALU, that is arithmetic and logic unit, control unit, input and output devices. Okay, so all of us know that computer consists of this. So this was the organization first proposed by the John von Neumann. Okay, so though the different blocks were existing or different devices were existing, but John von Neumann tried to organize the functions of the computer in these particular blocks, that is memory, arithmetic and logic unit, control unit, input and output devices. So any machine, any electronic device which is organized in this particular fashion qualify as the computer of von Neumann architecture type. All parts of the computers are connected together by bus. So these particular parts of the computer, they are connected by bus. Usually there are three sets of buses: address bus, data bus and control bus. Okay, so we shall see in detail this particular buses, the functions of this particular buses. These buses, they are nothing but the communication path. That is the lines which are connecting, which connects the CPU, which is nothing but the ALU and CU, with the memory and input-output devices. Computer structure is independent on computed problem. A computer is programmed with the content of the memory. Every computing step depends on previous step. Machine instructions and data are in the same memory. Memory is split to small cells with the same size. Their ordinal numbers are called address numbers. Okay, so these are the basic things of the computer. Okay, so whatever may be the problem you are going to solve, you will be using the same computer for that. So that is why it is called the general purpose. The structure of the computer is independent of the computing problem. Okay, though, but nowadays we are coming up with the different types of computers, microcontrollers and all that, so which are suitable for computing one type of doing one type of operation or the other type of operation. But basically the structure is more or less same. It, so for this computer there will be a stored program or steps which this particular computer follows. We call it as a program, and this particular program is stored in the memory. Whereas this particular program operates on the data, and the data and the program or the instruction, they are stored in the same memory. Okay, so this is how is the characteristics of the von Neumann architecture. Okay. In addition to this, program consists of sequence of instructions. Instructions are executed in order they are stored in the memory. Okay, so the program is stored in the memory in a sequential order, and one after another the instructions are executed unless there is a jump instruction or branching instruction. Sequence of instruction can be changed by unconditional or conditional jump instruction. Okay, and the instruction characteristics and the data numbers are represented in binary form. Okay, so each and everything is represented in binary form. Okay. So that is, your instructions are also in the binary and your data is also in the binary, because the computer is a digital electronic device and it understands only 0 and 1. This is how one can draw the diagram of the von Neumann architecture. So ALU, CU. Okay, so together this ALU and CU may be called as CPU, that is Central Processing Unit. Then there is a memory. There are input-output devices, and between the CPU or this ALU and memory, so there are three different types of buses. Usually these particular buses, they are the data bus, control bus, and usually the address bus. Okay, so here the flow of data is being shown between the various components of the computer. Okay. Whereas there is some other way also we draw this particular diagram of the computer. Okay, so data passes between every blocks through the data bus. Okay. So data may be passed between the memory and input-output devices. Okay, always it need not pass through memory. Sometimes it directly go to the ALU also. Okay, so not shown here, but this was the earlier architecture. Whereas the control signal, the purpose of the control unit is to provide the control signal and the control signal is provided to memory, it is provided to the input output devices, and the ALU, that is control unit. The job of the control unit is to generate the various control signals. Okay. This is another way, simplified way of the von Neumann architecture, that usually we draw this particular diagram of the computer in this fashion. CPU, which consists of ALU and CU, memory, okay, and the devices, that is input output devices, and connecting the CPU, memory, and the devices is the bus. Okay, so this particular bus, as already it is discussed, consists of the data bus, address bus, and control bus. Okay, so the control signals usually which are there on the control bus, so they are generated by the control unit which is there inside this particular CPU, whereas the data pass through the bus in half duplex mode from to or from CPU. That is, data either passes from CPU to the memory, okay, or on the same line, the data can pass from memory to CPU, or data can pass from CPU to the IO devices, or from IO devices to the CPU. Okay, sometimes it is also possible that the data can be transferred from IO devices directly to the memory, or data can be transferred from memory directly to the input output devices. Okay, so this is the von Neumann architecture that we use today, which we are very much familiar with. The advantages and disadvantages of the von Neumann architecture. So it has got a control unit gates data and instruction in the same way. From one unit, it is simplified design and development of the control unit. So one way is that it is the design is simplified. Uh, so data from memory and from devices are accessed in the same way. So the instructions, because of this, they are simple for the von Neumann architecture, whereas the memory organization is in the hands of the programmer. So uh, programmer can decide which memory can be used as a data memory, or which memory to be used as the program memory, because same memory is used. The main characteristics of the von Neumann architecture is that same memory is used as it can be used either as data memory, or it can be used as the program memory. Serial instruction processing does not allow parallel execution of the program. So this is one of the rather disadvantage of the von Neumann architecture. If the memory would have been different, then the parallel processing could have been done. Okay, so there are the other type of architecture which proposes this separate data memory and program memory, in which parallel processing is possible. So we shall see that architecture also. One bus is a bottleneck. So because everything is on one bus, so it is a bottleneck. So single bus is the characteristics of von Neumann architecture, but there are other architecture which uses more than one bus. Okay, and in that case, the speed of execution is higher. So only one information can be accessed at the same time. Instructions stored in the same memory as the data can be accidentally written by an error in a program, because same memory is used for writing the data and the program. So it may happen that accidentally in the part of the program some data may be overwritten, and that may corrupt the the data. Okay, so these are some of the advantages and disadvantages of this particular architecture. The other type of architecture, common architecture, is the Harvard architecture. Okay, so note this particular spelling, Harvard architecture. Okay, so this it is not hardwired, okay, or hardware architecture. It is Harvard architecture. Harvard is a university. Okay, it is world popular university. You may be knowing. So, because it was developed in the Harvard University in 1947, this architecture. So that is why this architecture is called the Harvard architecture. Okay. So how it is different than the von Neumann architecture? That CPU, there is a CPU, there are I/O devices, there is memory also, but memory is divided or isolated. The data memory is separate and program memory is separate. Okay, so that is the main characteristics of the Harvard architecture. Okay, whereas there are separate buses for the program memory and for the data memory. Okay, so this particular bus for the data memory is same as that of the I/O devices, whereas for the program memory the bus is separate. Okay, so that is why what happens if CPU is reading or working with the program memory at the same time simultaneously, it may work with the I/O devices or the data memory. Okay, so that is how this particular hardware architecture is different than the von Neumann architecture. And because of the isolate independent data buses for the data memory and program memory, this particular type of computers, they are faster than the von Neumann architecture. Okay, so this is the comparison between the Harvard versus von Neumann architecture. Programs organize the content of the memory and they can use the whole capacity of the installed memory. So memory is used efficiently in case of the Harvard architecture. In the case of von Neumann architecture, whereas in the Harvard architecture, uh, only program can be stored in the program memory and only data can be stored in the data memory. So in von Neumann architecture, one bus is simpler for the control unit design. Okay, so the design is simple because a single bus is to be there. But in hardware architecture, it is complex. You need to have two different buses. Development of the control unit is cheaper and faster for the von Neumann architecture. Computer with one bus is cheaper. Data and instructions are accessed in the same way. Okay, so that are the advantages of the von Neumann architecture. Its disadvantages: one bus, so for data and instruction, so there is a bottleneck. So at a time, only one transfer can happen. Error in the program can rewrite instructions and crash the program execution. Okay, so because same memory is used, so accidentally it may happen that data is written in the part where the program is stored. So there can be errors. Okay. Then two memories with the two buses allow parallel access to the data and instructions. So execution is 2 times faster in case of hardware architecture. Both memories can be produced by different technologies, that is flash, EEPROM or SRAM and DRAM. Okay. Both memories can use the different cell sizes. Okay, so because they are different, so you can use different types of memory in case of hardware architecture, whereas in von Neumann that flexibility is not there. Program can't rewrite itself, so that is the advantage with the hardware architecture. Okay. Its disadvantages: control unit for two buses in more complicated and so it is more expensive because two buses are there. Production of the computer with two buses is more expensive. Development of complicated control unit needs more time. and free data memory can't be used for instructions and vice versa. Okay, so this is how is the comparison between hardware and von Neumann architecture. Okay. So there are certain examples of von Neumann and hardware architecture. The general purpose computer that we use is von Neumann type of architecture, whereas the DSP processors, digital signal processors, or many of the microcontroller, so they belong to the hardware architecture. Okay. Now let us see the evolution of the computer, how computers uh, evolved from the First World War till today. Okay, so there are usually called so-called 3 to 4 generations of the computers. The first generation of the computer was constructed of vacuum tubes, relays, switches, crystal diodes, and passive components. Drum memories was used for the program storage. The typical example of the first generation computer was ENIAC, that is Electronic Numeric Integrator and Computer. The computer mentioned earlier, it is the technical the technical parameters for these computers were the 18,000 vacuum tubes, 7,200 crystal diodes, then 70,000 resistors, 10,000 capacitors and inductors, 1,500 relays, 6,000 switches, 5 million hand solenoid joints. Then weight of it has a weight of 30 tons. Power consumption was 200 kilowatt. Can you imagine 200 kilowatt? Then performance of up to 5,000 operations per second, whereas it was programmed in machine code. To change the program, 1 week was required. Okay, so to make just a simple change in the program, more than 1 week was required. Okay, so you can see the picture of that particular first computer, which was having about 18,000 tubes. Okay, and if any one of the tube is faulty, then you can see how it would be difficult to locate which tube is faulty, locate that tube, and then replace that particular tube. Okay, so that was so the whole room, in fact, is considered. It is not in fact room. It is a hall, a big hall, is a computer. Then this is the magnetic drum usually used for purpose of storing the data. Okay, so the devices that were used in the first generation. Then came the second generation of the computers, and the major change in the second generation of the computer, which was in between 1965 to 56 to 65, was replacement of the vacuum tubes. Okay, vacuum tubes, they take very large space, so they were replaced with the transistor, the semiconductor devices. And the transistor is a semiconductor invented in the Bell laboratories in 1947. Transistors allows computer to become smaller, faster, cheaper, and more energy efficient and more reliable than their first generation predecessors. Okay, so the magnetic drums was replaced by magnetic ferrite core memories technologies. Up to 16 kilobytes of the core memory was available. Program was read from punched card or tape. Output was printed. That means there were no monitors. For your information, there were no monitors and keyboards. The program was entered from punch cards and tape, whereas the output was printed back on the punch card or on the papers. Magnetic tapes and discs were used as the external memory. Programming moved from cryptic binary machine language to the symbolic language, or the early versions of the Fortran and COBOL. So these were the first generation higher level languages. First operating system was developed, and batch processing was used. So that was the characteristics. So this is now the picture of the second generation computer. So Tradic is the name of that particular computer. So first fully transistorized computer from AT&T, and that was using about 800 transistors. Another example of the second generation computer mainframe, ICT 1301. So typically fully transistorized mainframe from UK. So and then came the next generation, that is third generation of the computer from 1965 to 1980. So the characteristics of this particular computer was using the integrated circuit. Okay, so many transistors were integrated, were combined, were put together into a single circuit, that was called integrated circuit, that is IC. Okay, so use of ICs with the small and medium scale integration is a typical of the third generation computers. The miniaturized transistors on silicon drastically increased the speed of the computer. It decreased the size of the computer, and efficiency of the computer was hence improved or increased. So characteristics: fixed disks were used to save program from punched cards. Spooling was used, that is parallel I/O operation during process execution. First memory was made from the ICs, higher capacity and speed. The multi-programming to run more than one job at the same time was introduced for such computers. Time sharing to allow multi-user access to computers at the same time with keyboard and CRT monitors. So the keyboards and CRT monitors were used in the third generation computer. The complex OS such as OS 360 was developed by IBM, and it was used for various applications, including the scientific and business applications. So the use of computer was spread. It was not only in the research, but it was in the business also. The first mini computer was introduced. Okay, so that was the third generation. So you can see the third generation computer, IBM 360. Okay, this is the snapshot picture of that particular third generation computer. Then typically this is the terminal. Okay, this is not computer. This is not computer. This is the terminal only. It is not. So it has that. What is a terminal? Terminal consists of a monitor and keyboard. So there is only monitor and keyboard, and this particular monitor and keyboard is connected to the mainframe, and like this. So many mainframe were connected in this particular fashion. Many terminals were connected in this fashion to the mainframe, so that that particular, and the operating system that time, it was a multi-user operating system. So a single computer was shared. A single computer was shared, or it was used by many people. Okay, so you can so that is why the computers the computer that came after this, it was called a PC. What is a PC? PC is personal computer. That means a computer which is independent for a particular person, whereas the earlier the computers, they were not personal, they were shared. Okay, and the sharing was done with the help of the terminals like this. Okay, so this terminal consists of only monitor and keyboard. The fourth generation computers is characterized by the VLSI, very large scale integration ICs. Okay, nowadays we are having the ICs in which very large scale integration is used. Okay. The fourth generation computer is characterized. Okay, so the characteristics of this are the speed is increased and efficiency is still going up. Thousands of ICs were integrated to one silicon chip. The first single chip CPU was developed. Nowadays, whole of the CPU, central processing unit, comes into a single processor, and that we call it as a microprocessor or simply as a processor. Okay, so you are aware of the processors in the computers you are using. Nowadays, we are using Pentium processors in our machines. Okay. Of course, there are various versions of it: Core i3, Core i5, Core i7, and like that. Semiconductor memory, DRAM, SRAM were used in the main computers. So tape were not used. They were replaced by the secondary memory like hard disk and floppy disk. Multi-user OS with GUI network OS, distributed OS was developed. Parallelism, pipelining, cache memory, virtual memory were applied, and they were used in the better way. Many new programming languages like C, Pascal, now web-based languages, that is Java and Python, they are now being used. The color CRT monitors and keyboard and mouse was the feature of this. Okay. Now this is the comparison between the generations of the computers in the tabular form. So whatever we discuss, so is simply written in the tabular form here. Okay. Uh, so we shall, for now, we shall stop here, and we shall continue with the more details of the computer organization in the next class. Okay. I hope all of you have marked your attendance. Yes. Hmm?
Yes, sir.
Have you marked your attendance?
Yes, sir. Yes, sir.
Yes, sir.
Okay. Okay. Uh, So today we have started with the second part of the subject, that is computer organization. Okay, so we have finished with the digital electronics. As far as practicals are concerned, the practicals are only on the digital electronics. There will be no practicals on the computer organization, but if required, we shall have one or two practical, maybe study practical on computer organization. Okay. Now, for the purpose of some work related to the CET examination, I need to go immediately. So we shall stop here for today. We shall meet tomorrow. Okay. So bye. Good day. Should I increase the time limit for the attendance if some of you have not marked the attendance? It was up to
Yes,
8.
sir.
Huh?
Yes, sir.
Yes, sir.
Okay, I will make it up to uh, 9 o'clock. Before 9, you mark your attendance, and remaining time you can use, you can spend on Dell scene. Okay, from this weekend or next week, we shall uh, start with the actual practicals. Though already I have given the first practical to you, the code converter. Okay, so if you are able to implement it in this week, that is good. But from next week, I will be able to give full time to you for your theory and practicals. Okay, so for now we shall stop here. I have already extended the time. Those who have not marked their attendance, you can mark your attendance. Okay, you may leave the session now. Okay, so when all of you leave, the recording will stop at that time. Okay, so all of you leave the session now. Leave the session so that I will be able to close the meeting. Hurry up. Yes, Aniket, Vaishnavi, Rahul, leave the session. Siddesh, Nikita, are you there? Leave the session. Rahul, Siddesh, Nikita.